Welcome to RK Tutorials. Solutions to Engineering Mechanics 5th edition by S. Timoshenko, D.H. Young, J.V. Rao, Sukumar Pati. In this tutorial, we will discuss problem set 2.3, problem number 2.24. A ball rests on trough as shown in the figure. Determine the angle of tilt theta with the horizontal so that the reactive force at B will be 1/3 at A if all surfaces are perfectly smoothed. That means our interest is to find the value of theta so that the reaction at B is 1/3 of the reaction at A. Before going into the solution, please remember one concept. If any body is supported, then a reaction force will develop, and the reaction force is always perpendicular to the support and it is towards the body. Now with this concept, let us see what are the various forces that are acting on the ball. The first force is the self-weight, of course. Let the self-weight is Q. Next, since the ball is rests on the trough and it is supports at points A and B, reaction force will develop at point A and B. Let the reaction force at A is RA. Now according to that concept, the reaction force at A is perpendicular to this surface and it is towards the body. That's why the reaction force is shown like this. And if you extend this force will intersect here. Similarly, another reaction force will develop at B, which is perpendicular to this surface and it is towards the body. Let this reaction force is RB, and if you extend this force, this will intersect at this point. Now let us transfer all these forces onto a separate XY plane so that we can easily analyze this problem. The first force is Q, which acts along the vertical direction. The next force is RA, which is inclined. And the next force is RB, which is also an inclined force. Now our interest is to find the angles made by this RA and RB with either horizontal or vertical. First, let us see the angle made by RB. Now look at this. This surface makes an angle 30 degrees like this. This angle is given as 30 degrees. But this is the horizontal surface. These two are parallel. This is the horizontal line. This surface makes an angle theta that is given here. Now, what is the angle made by this inclined surface with the horizontal? This becomes 30 plus theta. Clear all of you? So this becomes 30 plus theta. Now, if this surface makes an angle 30 plus theta with the horizontal, its perpendicular makes an angle of 30 plus theta with the vertical. So this becomes 30 plus theta. This becomes 30 plus theta. Now similarly look at this. Now this surface makes an angle 30 like this. But already we know that this surface makes an angle theta. That means this surface makes an angle of 30 minus theta with the horizontal. That means this RA makes the same 30 minus theta but with the vertical 30 minus theta. So this will be represented like this, 30 minus theta. Now, just look at this. This is three force system, and all three forces are intersect at one particular point, and all three forces are divergent. So I can comfortably apply the concept of sine rule. That means Q divided by angle between these two forces. That is, how much is the angle between these two forces? Theta plus 30 plus theta plus 30 minus theta. Like that, I can find angle between all these three forces. I have prepared a separate video on the concept of sine rule. Please watch it from RK tutorials. Now, according to the sine rule, Q divided by angle between these two forces is 30 plus theta plus 30 minus theta. So you will get sine 60, Q by sine 60. And then RB divided by, I want angle between these two. You know that this is 90 degrees, but what about this? This is 30 plus theta, already you know. So this is 90 minus of 30 minus theta. So you will get 60 plus theta. So what is the total angle now? What is the total angle? 90 plus 60 plus theta. That means 150 plus theta. RB divided by sine 150 plus theta. Similarly, RA divided by angle between these two I required. So this, you know, this is 90 degrees and I want this angle. Given that this is 30 plus theta, we know it. So obviously this becomes 60 minus theta. So the total angle, so this total angle becomes 90 plus 60 minus theta, that is 150 minus 150 minus theta. RA divided by sine of 150 minus theta. Now, another condition is given that RB is RA by 3. This is the condition given. Now what I will do is, I will take these two equations. Sine 150 minus theta into RB is equal to RA into sine 150 plus theta. So I will substitute RB is equal to RA by 3. So I will get sine 150 minus theta into RA by 3 is equal to sine 150 plus theta into RA. So this I can further simplify. So I can send 3 that side. Then I will get sine 150 minus theta into RA is equal to 3 into sine 150 plus theta into RA. RA also gets cancelled. Then I will get sine 150 minus theta is equal to 3 into sine 150 plus theta. So this I can extend sine A cos B minus cos A sin B formula. So sine 150 cos theta minus cos 150 sin theta is equal to 3 into sine 150 cos theta plus cos 150 sin theta. I can substitute the corresponding value. Sine 150 is 0.5. So 0.5 cos theta and cos 150 is minus 0.866. So it becomes plus 0.866 into sin theta is equal to 3 into 0.5 cos theta minus 0.866 sin theta. This further I can simplify. So I can remove this. So 1.5 cos theta minus 2.6 sin theta. I can make all sin theta terms are one side and cos theta terms are one side. So the 2.6 sin theta plus 0.866 sin theta is equal to 1.5 cos theta minus 0.5 cos theta. So this becomes 3.466 sin theta is equal to cos theta, or I can say tan theta is equal to 1 by 3.466, that is 0.2885, or theta is equal to 16.09 degrees is the answer. The same problem you can also solve using the concept of resolution of a force. I have prepared a separate video on the concept of resolution of a force. Please watch it from RK tutorials. Now this is the free body diagram at the center of the ball. Now I can resolve all these three forces onto xy axis. Let us say this is x-axis and y-axis. Q is along y-axis, you need not to resolve. Now RA makes an angle 30 minus theta with the y-axis. So you can resolve this force along x-axis and y-axis. Y component becomes cos. RA into cos of 30 minus theta, the another one is sine, because RA makes 30 minus theta with the vertical. That's why y component becomes cos and x component is sine. RA into sine 30 minus theta is the x component. RA into cos 30 minus theta is the y component. Similarly, I can resolve this RB along x and y axis, and RB makes 30 plus theta with the y axis. That's why the vertical component becomes RB into cos 30 plus theta. The other one becomes a sine component. Now you can see the vertical component of the force, that is RB into cos 30 plus theta, and the horizontal component is RB into sine 30 plus theta. Now I can apply the equilibrium condition. Sigma fx is equal to 0. I will take this side is my positive side. RA into sine 30 minus theta is equal to RB into sine 30 plus theta. Given that RB is equal to RA by 3. So I can substitute there RA into sine 30 minus theta. I will expand, that is sine A, that is sine 30, that is 0.5 cos theta, minus cos 30, that is 0.866 into sine theta, is equal to RA by 3 into 0.5 cos theta plus 0.866 sine theta. So RA gets cancelled and I can simplify further. So 3 I will send towards this side. Then I will get 1.5 cos theta minus 2.6 sine theta is equal to 0.5 cos theta plus 0.866 sine theta. So this I can further simplify. I will send 0.5 cos theta this side. So 1.5 minus 0.5, this becomes cos theta. And I will send 2.6 sine theta towards this side. 0.866 plus 2.6, which becomes 3.466. Or I can say tan theta is equal to 0.2885, or theta is equal to 16.09 degrees. Is the answer for this problem.